Show that the right circular cone of the least curved surface area and the given volume has an altitude equal to root 2 times the radius of the base. So first thing first, we need a diagram. So what is that we are looking at? We're looking at a cone. So this is a cone. Okay. Now, what we have here is the radius of r and the altitude of h, and the slant height is L, and that's 90 degree. So that's making it a right circular cone. Least curved surface, only the curved surface area is what we are talking about, not the base. And given volume means this is fixed and this can vary. So we have to prove that. First of all, let me write a statement. Let's consider a right circular cone of height h, base radius r, and slant height L. So we have to prove altitude, that is h, is equal to root 2 times the r for least curved surface area. Okay, I'm going to make use of triangles, trigonometry to be specific, to solve this. Okay, so let me start off with a diagram to help us with this. So first thing first, I have, this is r, that's h, and I'll take this as theta, and that's L. So we have sine theta is equal to opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is opposite by adjacent. Okay, so this is all from the figure. So we have, say, this is ABC. I think I need not do that. This is from figure. Okay, now let's start off with volume of, say, the cone. Let's express in terms of theta and r only. Okay guys, remember this is fixed. Okay, this is not going to vary. So we're going to express everything in terms of theta and r. That is, in place of h, I'm going to write this as sine, not sine, sorry, I need, okay, tan theta into r. So basically this would be 1 by 3 pi r cube into tan of theta. We got this from, say, 3. That's enough. Right? How will this help? This is something that we'll see in time. Then curved surface area of the cone is given by pi RL. That's a traditional formula. We're going to re-express this as, in place of L, I'm going to write it as r square by cos theta. All I'm doing is simple substitution, say from 2. This I'm calling it as 2. Okay, now, so these are your formulas. And now starts the real thing. We are to minimize this. This is the one which is varying. So differentiating curved surface area, I'm going to write it as C of r comma theta with respect to theta, with respect to r. I'll do it with r itself. Okay, so now we have this to be equal to pi is a constant. I'm taking it out. So differentiation of 2r square is 2r, and I'm going to take this as secant theta, right? I can rewrite this as pi r square secant theta. So I'm differentiating this. Then I'm going to put a plus. Then we have r square. Differentiation of secant theta is secant theta tan theta. And d theta by dr. So it's a simple thing that if I change the radius, right? Say for example, if I reduce the radius, what happens? The angle will change. Is it not? Right? For a fixed volume, if I do all of this, the angle will change. So that's the funda. Okay? So it is dependent on, the angle is dependent on r. You can see it from here also. Right? It's dependent on r. So because of that, we have this particular expression. Now, to further solve this, I need an expression for dr by d theta. Where will I get it? Obviously from this particular expression. So this I'll call it as A. So differentiating volume with respect to R. Okay. So next step is expression for d theta by dr by differentiating volume with respect to R. Again, all this is something that is not your traditional way, I know, but I feel using this is a lot simpler and it's easier to handle. It's simple trigonometry and you guys know all of this, right? Okay, let me continue. So differentiation of any constant item is 0, okay, and on the RHS we have this expression. So I think this is 3r square tan theta, if I'm right, plus r cube secant square theta d theta by dr, closing the brackets. Again, this is happening because volume is constant, right? Whatever I do, this has to remain constant. That is the whole question. So that's 0. Okay, and now I can cancel this and this, and even r square is common. If I take r square common, so this will become 1. This entire thing cancels and there's nothing else. Okay, I did a bit of fast calculation because there's a lot of things to write over here. It's no point in waiting around. So this would be minus 3 tan theta divided by r secant square theta is equal to d theta by dr. You can take a pause and have a look. So this should be the level of calculation. This is how fast you should be able to calculate. Okay, right? And therefore this particular expression would be pi times of 2r secant theta plus r square secant theta tan theta. Since this is minus, right, d theta by dr is minus, so I'm going to write that itself, 3 by r tan theta by secant square theta. So this and this will get cancelled, secant and this will get cancelled, and we have the following scenario. Now, zeros of the above expression will look like 0 is equal to pi times of, I can take r common and nothing else, right? R I can take common and we have 2 secant theta minus 3 tan square theta cos theta. Agree? Okay, I just wrote it for simplicity. It's going to make things simpler. So basically all of this will get cancelled and bit of rearranging, and we have okay, let me do this. Tan 3 tan square theta cos theta is equal to secant theta, right? So we need a bit of simplification that should happen now. So this is 3 sine square theta by cos theta into cos theta is equal to 2 by cos theta. I'm converting everything to sine and cos. That's our go-to step, right, in trigonometry. This cos and this is square, by the way. So this and this and this, everything gets cancelled, and we have sine square theta is equal to 2. Therefore, sine of theta is equal to root 2 by root of 3. A small diagram will help over here. So basically we are looking at this being theta. So opposite is root 2, this is root 3 on calculation, right? If I take this as ABC, or let's keep this itself. So all these are with constants k. Okay. So this implies height is root 2. Slant height is some constant k, okay? And therefore your r would be k, where k is constant. And how did I get r to be k? 1, basically 1. Pythagoras theorem. Right? Okay, from this I can clearly tell your height and base, they have a relationship. Sorry, height and base only, radius of the base, they have the relationship that we needed. Okay, so we are pretty much done. We just have to show that this is the least value possible. So till now things have been very neat and clean. So this is where it gets a bit complicated. Okay, in some sense it is a bit hard. So we are checking for. So this is done, right? I hope you guys are clear with this. Now the last step to do is check the nature of turning point. So for that we need to differentiate with respect to theta again. Okay, so that expression is over here. So it's for my convenience. So I'm going to cancel this, this is cancelled, this is cancelled. So this is basically tan square theta into cos theta, right? So we have r comma theta is equal to pi r secant theta minus 3 tan square theta cos theta. Is that correct? Take a pause and have a look. Okay, so we can further simplify this. To be honest, I can rewrite this as secant square theta and all of that. So maybe that would help, I guess, because anyways we need to differentiate and so on and so forth, right? So it would be better for us to simplify this. Okay, so let's do that. I'll do that, because if not you guys will get confused. We can use product rule over there. Okay, let me just do this off. So we have r secant theta minus 3. I'm going to rewrite this as secant square theta minus 1 cos of theta. Okay, so this is pi r secant theta minus, we need to multiply this. So this would be secant square theta into cos theta is secant theta. Okay, plus 3 cos theta. Agree? So all in all, what do we have? We have pi r 3 cos theta minus 2 secant theta. Okay, just take a pause and have a look. Right, everything okay? Just let me have a look. Oh, I missed 2 guys over there. There was the 2 over here, 2 over there, 2 over there, and so this is just 1. And now I need to differentiate. So this is the hard part, getting these expressions. But if you are good with trigonometry, then all this is simple. So I'm making the process simple. That's my agenda. So it might look a bit lengthy, but it's simpler. So we have this to be a product rule. So I'm taking differentiation of r, just copying the second term, because differentiation of r with respect to r is 1. Okay, so if you guys want to, and then plus pi r, see, it's so simple now, minus 3 sine theta minus secant theta tan theta, and the differentiation of, right, theta in both of this. So I'm taking it out, but d theta by dr, yes, that itself is a negative term. Where is it? Here. So I need to substitute that. Actually, I should have done it a bit later. Okay, so let me keep that. Okay guys, so we have this, and in place of this I'm going to substitute this. So now it's time for us to at last substitute and stuff. Yes, it looks complicated, but if you do it yourself, then you'll find that it's not that difficult. Okay, so let's look at it. So we have cos theta. Cos is what? Adjacent by hypotenuse. So let us do this. Pi times of 3 into cos theta is 1 by root 3. This is also root 3, sorry. This term goes to 0. Right? So it's not that hard. Please think about it. Then we have this r and this r gets cancelled, and then we have overall there's minus, minus, and minus, so this will be continue to be plus, and we have 3. Sine is root 2 by root 3. Then we have this to be plus root 3, and tan is 1 by root 2, I guess, or root 2 by 1. Tan is opposite. Okay, root 2 by 1. And finally we have 3 root 2, and secant square is 3 itself. So this will cancel, this will get cancelled. All of this is basically a positive term. This is greater than 0. And from this we can infer that, hope you guys remember, the critical point is a point of minimum. It's a local minimum. That's it. And so therefore tan theta, which is equal to root 2 by 1, which in turn is equal to opposite by this, therefore h is equal to root 2 into r, hence proved. Where is it? Right, that's the question, I guess. Altitude is equal to 2 times the radius of the base. Altitude is equal to 2 times the Radius of base. Why to miss that, right? It's a very big answer. Let's not give even a smallest chance to lose any mark. Okay, that's it. Yes, I agree that there is a lot of writing, but I really honestly feel that it's a very simple process. It's lengthy, I agree, but systematically done, it's a very simple process. Compared to other methodology, you can see it's very clear and there's no complicated terms. It's a bit, not bit, it's lengthy. Yeah, you can pause and have a look.